A sample of polonium-210 has an initial mass of 300 grams and decays at a rate dm dt is negative 0.005 m. M is the mass in grams and T is the time in days. Find a model for M in the form M equals AE to the KT. Find the mass of polonium-210 in the sample after 10 days, and what is the half-life of the sample. So we want to solve this differential equation. It's a separable differential equation, so we're going to separate and integrate. That gives us natural log m is negative 0.005t plus a constant. Take the exponential function of both sides and remember that on this side the exponential and the natural log are inverse functions. So if we take the exponential function of log m, we just end up with m. Now remember, here we can use an index law. We did that in the previous example. And so we get e to the c times e to the negative 0.005t. And of course, e to the c is itself just a constant, so call it a. Now, m is 300 when t is 0, and of course, e to the 0 is 1. So that tells us that a is 300, and so m is going to be 300 e to the negative 0.005t. So in part B, we want to know after 10 days. So that's just a case of substituting in t equals 10 and calculating. Finally, we want to know the half-life of the sample. Well, that's going to be when the exponential equals 0.5. Remember, if that was 0.5, m would now be 150. So we'd have half of the original amount. And we just need to solve this. So we'll take the natural log of both sides, and again remembering natural log and exponential are inverse functions, we get negative 0.005 t. Log e is log of 0.5, and of course log of e is just 1. And so t is going to be log of 0.5 over negative 0.005, and that gives us 138.6 days.